People often ask me why I'm against kernel-level anti-cheats in games, and I usually respond with hypotheticals, things that could happen when you let unwanted junk into your kernel. Well, now we have an example of something that did happen when you let unwanted junk into your kernel. In case you've been living under a rock and haven't heard about the 2024 CrowdStrike incident, let me give you a brief summary, but I won't go into the details since plenty of other people have covered that already. The Wikipedia article actually summarizes this quite well. On the 19th of July of 2024, American cybersecurity company CrowdStrike distributed a faulty update to its security software that caused an estimated 8.5 million computers running Microsoft Windows to crash and left them unable to properly restart. This caused what has been called the largest outage in the history of information technology and historic in scale. And many businesses were affected. Airports, banks, hotels, hospitals, manufacturing, and so on. This was a really big deal. Only a couple days after this happened, the financial damage has been estimated to be in the range of billions of dollars. So what happened? Well, CrowdStrike produces a whole suite of security software products, and in particular, their Falcon sensor product, which is a vulnerability scanner, installs an endpoint sensor inside your operating system at the kernel level on individual computers to detect and prevent threats. As with many other pieces of security software, patches are routinely distributed to its clients in order to enable their computers to address new threats. Unfortunately, they pushed a broken update to its software that put machines into a boot loop or a moot recovery mode. And from there, total chaos happened. Flights were grounded, banks had to shut down services, trains weren't running, hospitals had to cancel appointments. Unfortunately, the broken update caused these systems to all crash. And on computers that had disk encryption enabled, which was often the case in corporate computer setups, it made it worse because fixing the problem could require a recovery stored on a server that itself had crashed. So what does this have to do with anti-cheat? Well, I think this is a perfect demonstration of why you shouldn't let random crap install itself into your operating system kernel. Had this software been running in user space, this wouldn't have happened. The worst thing that might have happened is, well, the software itself might have crashed, but it definitely wouldn't cause a boot loop that made the computer basically unusable. Why is that the case? Well, because the whole point of an operating system is that it isolates user space processes from each other and from the hardware. It does a whole lot of different things that I won't get into the details of to make sure that each process is completely separate and one process crashing shouldn't bring down the whole system. But since this piece of software was installed directly into the kernel, well, the only crash handler left at that point was the blue screen of death, right? It just prints out some information about what the specific error was, and then it shuts down the system. Because at the kernel level, that's all it can really do. It's not expecting to run its own code in an isolated environment, because that's not what it's designed for. And before any Linux users chime in saying, oh, this is a Windows problem, the Microsoft Windows kernel is poorly written. No, this would have happened on Linux as well. If you install a kernel module that completely breaks your system, Linux isn't going to handle that very well either. This has nothing to do with whether the kernel is open source or proprietary, and everything to do with where this program was installed and what level of privilege it was given. In software engineering, there's this principle of least privilege, which is that a task should only have the minimum permissions it needs in order to do whatever it needs to do. So, for example, a file browser, all it really needs is permission to access the file system to see what files you have. It shouldn't need to have access to, I don't know, opening VPN connections or anything like that. And of course, the inverse is true as well. If you have an application that is a VPN client, probably doesn't need access to arbitrary files within the file system. And so by isolating the permissions that it has to the minimum that it needs to get its job done, you prevent issues like this. Because if something goes wrong, well then it'll only affect the things that it has access to. Unfortunately, for cybersecurity antivirus type software, generally they want access to your entire system, just because of the way that that kind of software works, right? It needs to scan your entire system, it needs to see what's in the memory, it needs to do all sorts of things to try to prevent viruses from running and remove them if necessary. So in this case, that's not exactly applicable. I can see why they wanted this software to run at the kernel level. The second issue with the way that this was implemented was the lack of fallbacks and failsafes. Systems affected by this issue would go into a boot loop, where they would start up and immediately crash and shut down. And so when you tried to start it up again, well, the same thing would happen and you'd get absolutely nowhere. It seems like this code was written with the assumption that, well, this module would never crash, so why would we need to have a failsafe in case it did? One example of a failsafe, just off the top of my head, is if the system crashed 3 times in the past 10 minutes, maybe don't load the module, or something like that. That way you'd have degraded functionality, but at least it wouldn't completely destroy the machine. You'd still be able to use it, just without the protections. And I think that's definitely better than the machine being completely unusable. It seems like the code was written with the assumption that nothing would ever go wrong, which is unfortunately a common enough mentality among software engineers. The programs I write never have bugs. Why would they possibly crash? I don't need to handle that. Unfortunately, the real world is a bit different. Bugs will happen. They're inevitable. Your software will have issues with it. That's why you need to have these kinds of fail-safes in place. Unfortunately, in this case, they just didn't. And apparently the update wasn't even tested properly. There's some speculation going on that the update was not put through routine patch management procedures, such as testing the update in a sandbox to verify that there were no issues. Which, again, for something that you're giving as much privilege as possible, you're running it directly in the kernel, you're giving it full access to everything, you should at least make sure that it actually works. Like, that seems like the absolute bare minimum that you could do. But hey, what do I know? So what does this have to do with anti-cheats? Well, anti-cheats also operate at the kernel level. At least many of them do. For example, EAC, Easy Anti-Cheat. EAAC, Electronic Arts Anti-Cheat. EAAAC. Okay, that one is a joke. This is what happens when something goes wrong with code that's running at the kernel level. And even though nothing like this has happened with anti-cheat yet, anti-cheat software isn't perfect either. And these anti-cheat solutions absolutely do run in the kernel. Here is a deep dive on EA anti-cheat for PC from EA themselves. And in their FAQ, why is kernel-level anti-cheat needed? This varies on a game-by-game basis. For games that are highly competitive and contain many online modes like FIFA 23, kernel mode protection is absolutely vital. When cheat programs operate in kernel space, they can make their cheat functionally invisible to anti-cheat solutions that live in user mode. This is true. Unfortunately, the last few years have seen a large increase in cheats and cheat techniques operating in kernel mode, so the only reliable way to detect and block these is to have our anti-cheat operate there as well. This to me just sounds like an arms race. The cheat users are escalating the things that they're doing, so we have to escalate as well. Unfortunately, in this scenario, everyone loses. With FIFA 23, we'll see new and exciting crossplay features. In addition to EA anti-cheat protecting our blah 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 blah, they don't want cheaters basically. Which, I mean, fair enough, no one likes cheaters, but I still think that installing things inside your kernel to enforce that is going too far. I'd like to see a lot more anti-cheats that are running on the server, using things like machine learning to detect players that aren't playing like a human would play. Because fundamentally, that's what it's all about, right? Is separating the real people from playing the game, people using automated tools to play the game. And those tools will never be able to perfectly replicate what a human does. If we scroll down a bit, I can only play single-player modes on games like FIFA. Why do I need EA anti-cheat? That's a great question. Why should an anti-cheat be installed in a single-player context? Cheat developers use single-player game modes to reverse engineer a game or experiment with tampered game files to help them develop a cheat, then bring those alterations back into online multiplayer game modes. In addition to preventing active cheating during online play, EA Anti-Cheat also prevents cheat developers from using single-player modes in these ways. Protecting single-player game modes is necessary to hamper cheat development. I'm not sure I agree with this. I can definitely see how they'd think that reverse engineering a game would allow people to develop cheats more easily because, well, I'm not familiar with how cheats are actually developed, but I assume you'd need to reverse engineer some parts of the game. But to me, this sounds more like an issue of protecting the game files themselves, whether that's through obfuscating the code or encrypting certain things within the game itself. But this doesn't really sound like something the anti-cheat should be doing, so I don't really know why that's, like, that justification seems off to me. Here's another interesting question. Does EA Anti-Cheat let EA see my browsing history, personal files, or things like that? Player privacy is a top concern, blah blah blah. EA Anti-Cheat will only look at what it needs for anti-cheat purposes in our games, and we have limited the information that it collects. If you have a process on your PC that is trying to interact with our game, EA Anti-Cheat could see that and respond. However, everything else is off limits. EA Anti-Cheat does not gather any information about, okay, blah blah blah, and we have a privacy policy. This is an answer that I really don't like. I mean, given that that's how the anti-cheat works, that it runs in the kernel, this is probably the best answer they could have given. But notice how they don't say it can't see any of that, or it can't interact with processes other than the ones that are directly interacting with the game. No, it's just saying that they don't do that. In other words, you're really trusting EA here. They're saying that that's what they do. They're saying that they're not going to touch any of your personal data, but unfortunately, there's no way to verify that because it's closed source, obviously, and it runs in the kernel, so you can't even use some usual inspection techniques in order to try to figure out what it's doing. So really, you're at the mercy of EA here. And you know what? Maybe this is correct. Maybe they never look at any of that information. And perhaps there aren't even any bugs in this implementation that would cause it to, leak any information, even though that kind of thing definitely happens. Even in that case, it's still a possible attack vector for someone to exploit. Suppose someone gets access to the EA servers somehow, they hack into their systems, well then they could inject malicious code into the EA anti-cheat that does whatever they want. And so even though EA itself didn't do it, they essentially put a backdoor into your computer that lets someone else do it. Which brings me to the next question. How do I know that EA Anti-Cheat is not introducing any security vulnerabilities to my PC? Our game and security and anti-cheat team is composed of some of the best security engineers in the world, and we are passionate about ensuring that our software does not cause any security vulnerabilities. Trust me, my code has no bugs. But this is actually a good response. Getting third-party auditing is about the best that you can do in a case like this. So I will give them points for that. And game systems being used as a vector for attacks absolutely has happened in the past. Here we have CVE 2021-30481, source engine remote code execution via game invites. I won't go into the details here. Read this blog post, I'll link it in the description if you want to know more, but really the title speaks for itself. Remote code execution simply by sending someone a maliciously crafted game invite. Here's another one, CrowdStrike global offsets, reliable remote code execution. Again, I won't go into the details, read the blog post if you want to know more. Here's an example from a company other than Valve, analyzing Genshin Impact's anti-cheat module. This blog post goes into how the anti-cheat works, and how it was broken. In August 2022, Trend Micro reported on a ransomware that uses Genshin Impact's anti-cheat drivers to bypass kernel-level privileges. If you want to know more, read the blog post. Also, check out some of the other blog posts by this person. Understanding kernel-level anti-cheats in online games. If you want to know more, this is a good place to start. Fantastic art, by the way. If you like it, check out Atomic Arctic, who was commissioned to create this cover illustration. But okay, these are all issues with malicious actors without the game developer really intending for that to happen. So here's an example where it's the game developer putting malware into your computer. ACE, or better known as Anti-Cheat Expert, is, as the name suggests, an anti-cheat made by the tech giant Tencent. In today's digital age, the line between ensuring fair play in online gaming and safeguarding personal privacy is becoming increasingly blurred, unfortunately. That's why I took a look into ACE, I being the blog author here, not myself. And to be honest, the findings didn't completely shock me. And if we scroll down here, anti-cheats usually use the game's HWND, their window handle, to take screenshots. ACE, however, wants to be the middle child in the anti-cheat family. Instead of taking a screenshot of only the game, or at least of only the game's window size, it takes a screenshot of the entire display. Nice. Now, words are just words, and if you can't prove what you're saying. So, here's the following code, taken directly out of the binary. And the rest of the blog post goes into detail about exactly how this takes a screenshot of your entire display. I personally can't verify that what it's saying is true because I'm not familiar with these Windows APIs, but I'm going to take this at face value and say that yes, ACE, anti-cheat, does indeed take pictures of your entire display. And so what can we do about all this? Kernel-level anti-cheats have a lot of problems, whether that's security vulnerabilities, having to trust the game developer to not do sketchy things like taking screenshots of your entire computer, issues with security vulnerabilities, and even remote code execution. What can we as consumers do to prevent this. Unfortunately, the only real answer is to just not play games that use them. Unless you want to risk getting banned by trying to circumvent the anti-cheat, which, to be honest, I don't recommend. I think the circumvention methods probably open up even more opportunities for security vulnerabilities, so I definitely wouldn't want to use that on my computer personally. So the only thing we can really do is to just not buy and play those games, and hopefully that sends game developers a message that this is not acceptable, and that they should invest more into server-side anti-cheat rather than trying to do this client-side. Because really, at the end of the day, a user should have full access to their computer, and if they have full access, they're always going to be able to find some way to circumvent these things. So I guess, go vote with your wallet. Seems like that's all we can do. Thanks for watching.